So let us begin our today's session. So in the previous class, we have discussed about skew lines and the concept of shortest distance is described earlier. So in today's session, I want to take some problems based on shortest distance. Later, I am going to take some of the previous year questions. Then we conclude our today's discussion on right line. Then we start the new topic, that is sphere. Okay. So that will be the module of today's session. So please take a note of it. So I think everyone will know what is meant by shortest distance and how we are calculating it. Am I correct? All right. Now let us take the problem. Find shortest distance and line of SD for the line equations are given by x minus 3 by 3 is equal to y minus 8 by minus 1 equal to z minus 3 by 1 and x plus 3 by minus 3 is equal to y plus 7 by 2 equal to z minus 6 by 4. So please take a note of the lines. Now we discuss with the procedure. So earlier we have mentioned that we are going to calculate the shortest distance for three possible cases: when both lines are given in symmetric form, when the lines are of mixed type, and the third case is if both lines are given in unsymmetric form. So for each model, I want to take one problem. That is enough for the discussion. Okay. So is it clear to you? Right. Now, if you visualize the picture for the problem, let us say that this is line 1 and line 2, which are given in symmetric form. Always the shortest distance line is perpendicular to the given lines, the SD line. In other words, we will find a line which is exactly perpendicular to both the lines and which intersects them. So SD is nothing but the distance between the 2 points where the SD line meets the given lines. Okay. Now, for the first line, let us write the parametric form. If you take that this is equal to R, then you have x is equal to 3R plus 3, y is equal to minus R plus 8, z is equal to R plus 3. So every point on L1 will be of this form for some R. So the point P is also of the same form. Similarly, if you write the value is equal to S here for the consideration of parametric form, you have x is equal to minus 3s minus 3, y is equal to 2s minus 7, z is equal to 4s plus 6. So every point on L2 will be of this form. So Q is also of the same form for some S. Now I am going to calculate the drs of PQ, because I have to know what is the value of R, what is the value of S, so that I can calculate the points P and Q. The distance between them is nothing but the shortest distance. Accepted? Are you getting the idea? Now, if you calculate drs of PQ, since PQ is perpendicular to both the lines, applying perpendicularity condition for the drs, we can calculate the value of R and value of S as it is. So drs of PQ, you can consider either of the model. So you have minus 3S, minus 3R, minus 6, then 2S plus R, minus 15, and again you have 4S minus R plus 3. These are the drs of PQ. Since PQ is perpendicular to line 1, so for the drs 3 minus 1 1, and for this we apply the condition A1 A2 plus B1 B2 plus C1 C2 equal to 0. So I am writing the simplified answer. So if you simplify that, you are going to get the equation as 11R plus 7S equal to 0. Similarly, if you apply the same perpendicularity condition for these drs and minus 3, 2, 4, you will get the other equation as (7R plus 29S equal to 0). So actually here constants are eliminated. Sometimes you will get constants also for solving the equations. So on solving these two, you will get that R is equal to 0 and S is equal to 0. So substituting R and S values, the respective points of P and Q are nothing but, one point is 383, another point is minus 3, minus 7 and 6. Now you have determined the points P and also Q, hence the distance between these two, applying the distance formula, square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. For the 2 points, I think you are going to get the value as square root of 270. Now, any questions for anybody over this approach? Right. And if you want to find the equation of line of SD, since 2 points are known on the line, are you able to write the line equation or not? We have the formula x minus x1 by x2 minus x1 equals to y minus y1 by y2 minus y1 equals to z minus z1 by z2 minus z1. So using that formula for the 2 points, it is nothing but the line of SD. Okay. So please take a note of it, then inform. I will take the second case for calculating the SD as well as SD line. Now let us discuss the case that where one line is given in symmetric form, the other is given in unsymmetric form. So let us take the problem that x by 4 is equal to y plus 1 by 3 equals to z minus 2 by 2, and the second line is given by 5x minus 2y minus 3z plus 6 equal to 0, that equals to x minus 3y plus 2z minus 3. Now the question tag is same. We have to calculate the shortest distance and also the line of SD here. So I mentioned that, let us imagine the picture like this. So here the first line is given in symmetric form, the other in unsymmetric form. So let us imagine that it is given like this. Now, how to calculate the shortest distance between these two lines? Any guesses for anybody? Right? So I say that let us calculate a plane which is passing through the second line and parallel to first line. So I want to construct a plane which is passing through line 2 and parallel to line 1. So let us imagine this, it is coming to be like this. So these two are parallel. Now what happens if you take any point on the first line, the distance between the point and this plane is nothing but the SD. That was the concept behind it. Okay? Clear now? Since it is given in unsymmetric form, in order to calculate the plane equation, we will make use of the formula that pi 1 plus lambda pi 2 equal to 0. So I am using that formula to calculate a new plane which is passing through second line and parallel to L1. So clear to everyone? So you can visualize that how it is going to be happen. Any doubts for anybody? Right. Now applying the condition here, so let us take the values as common, the coefficients. Now what happens, since the plane is parallel to the line, if you take normal to the plane, the normal and the line both are perpendicular. So the normal of the plane is perpendicular to the first line. So we are going to apply the perpendicularity condition for first line drs and the plane normal drs. Therefore you have that 4 into 5 plus lambda plus 3 into minus 2 minus 3 lambda plus 2 into minus 3 plus 2 lambda equal to 0. I think which is going to give us that lambda is equal to 8. So substituting the value of lambda, you will get the plane equation as 13x minus 26y plus 13z minus 18 equal to 0. So please take a note of this result. If you have any other queries, you can ask. I think everyone has got the idea how SD is going to be happen if you consider a parallel plane, right? We have taken the plane equation in such a way, that's why I mentioned that I am constructing a new plane which is passing through line 2 and parallel to line 1. That is my assumption. Every plane passing through L2 is nothing but pi 1 plus lambda pi 2 equal to 0 form. Here the lambda will be determined as per our need. You can use parallel, passing through a point, perpendicularity, passing through coordinate planes, anything you can apply for the condition to determine the lambda. So if the plane is parallel to L1, then normal will be perpendicular to that one, right? That was the idea behind it. So here lambda is a predeterminate as per our condition. So you are defining lambda or you are finding lambda as per our required choice. That was the idea here. So is this part clear for everyone? Now let us go with the second part of the problem, that I need to calculate the line of SD here. So I want to draw a new diagram here for your better understanding. So this is line 1 and this is line 2. Now let us assume that this is the SD line. Already we have calculated a plane in this manner. Which is passing through L2 and parallel to L1. So in order to write the equation of SD line, since it is not possible to represent the line equation in symmetric form here, so we are representing the line of SD in unsymmetric form. So what does it mean? I need to calculate two plane equations such that the intersection is nothing but SD line. So how I am constructing the two planes that, so one plane I take that passing through line 2 and perpendicular to the plane which I already determined that. This is one plane I am finding now. Now I am finding the second plane passing through L1 and perpendicular to the same plane again. Now what happens? The intersection of these two lines is nothing but a line here. The two planes intersection. That I am calling actually the line of SD. Fine? Did you get the concept? Everyone? Right. Now, first I go with this part. What is the property of this plane? Passing through second line, perpendicular to the plane which I already found. So again I need to rewrite the same thing. Pi 1 plus lambda pi 2 equal to 0, substituting the values, taking the values as constant. Up to this, the three steps are common. Here, the fourth step varies. Since this plane is perpendicular to this plane, so for applying perpendicularity condition, I should consider these DRs. So 13 minus 26 and 13. That I am actually substituting there. Okay. Now, from this, you will get that lambda is equal to minus 2 by 3. So, if you substitute lambda value there, I hope you are going to get the equation as 13x minus 13z plus 24 equal to 0. So the same technique pi 1 plus lambda pi 2 equal to 0 will be applied again to determine this plane. Is it clear for all? Any questions? Right. Now I have to find other one. So for this plane, I have given a straightaway formula. So the formula is of determinant model, determinant of x minus x1, y minus y1, z minus z1, L1, M1, L1, L2, M2, N2 equal to 0. This formula I have given earlier, which is of very use. So here these two parts are nothing but taken from the first line. So x minus 0, y plus 1, z minus 2, 4, 3, 2. I have substituted line 1 values as it is. And since the plane is perpendicular to this one, I will take other things as 13 minus 26, 13 equal to 0. Now if you simplify the determinant value, then I will say you are going to get the plane equation as now I got two plane equations. I will write these two plane equations together so that I will have the line of SD. So please take a note of them. After noting, please tell. Any doubts or any queries for anybody here over what we did actually? Exactly. The shaded planes both are perpendicular to the plane which we already found earlier. That's why you can observe the DRs which are taken there. Here also you have taken the same DRs. Here the values belongs to line 1, DRs here. Here the plane values belong to the new one and DRs belong to the previous one. Agreed? So it is just like that. Suppose this is the plane which I have obtained parallel earlier. Now what happens? I am finding a plane which is perpendicular from the top position, and I am finding a plane which is perpendicular from the bottom position. So these two will intersect. That is nothing but the line of SD. It is just like piercing a stick here, which is supported of one plane on the top, one plane on the bottom. Right? Clear now? So for every problem, we have to calculate two things. One, equation to line of SD. Second, the shortest distance value. So here, calculating distance line is a little lengthy procedure. So I have discussed that thing now. Now how to calculate SD? So if you remember the previous step, what I mentioned, we got a parallel plane here. If you take any point on the first line, distance from point to plane is nothing but SD. That is my view earlier. So I want to calculate SD value here. If you observe, the point on the first line is nothing but 0, -1, 2. And this is our plane which we have considered. So I want to calculate the distance from the point and to the plane. So you have the formula that modulus of ax1 plus by1 plus cz1 plus d by square root of a square plus b square plus c square. So x1, y1, z1 is nothing but 0, -1, 2, a, b, c, d, nothing but 13, -26, 13, -18. So if you substitute the values there, you will get that the value is nothing but 34 by 13 root 6, the value. So simplification is not required. You have a numerator value, you have a denominator value, that's it. So if this problem is clear, I want to take the new one. After noting, please inform. Yes, understand that you are going to calculate SD by taking any point on the first line and the plane. So if you observe the numerator values on the line, here 0 is x coordinate, -1 is y coordinate, 2 is z coordinate. So I am calculating the distance from point to plane. Point is taken on line 1. So what point I need to consider? Which is given in the equation itself. The plane which you have already found. Right. Now I want to discuss the case calculating shortest distance and line of SD if both lines are given in unsymmetric form. So let me take the problem first. It is a little lengthy procedure, but you like to do, right? And the approach is very similar because we have done one problem on coplanarity if both lines are given in unsymmetric form by taking lambda and mu earlier. So please recollect that. If you have the notes available, please take a look on that. So here the question is, this is line 1 and this is line 2. So both lines are given in unsymmetric form. I have to calculate SD and also SD line. So to avoid the confusion in drawing the diagram, straight away I take that so I am not writing the unsymmetric form thing in the picture. So you need to understand that these are two lines given in unsymmetric form. So to calculate SD, the logic behind this is I am calculating two planes which are parallel to each other. So this is one plane I am considering passing through L1. This is another plane passing through L2. So I am saying that these are parallel to each other, so that the difference between them is nothing but SD. So that was the idea for the lines which are given in unsymmetric form, right? So did you get the context here? Any questions for anybody? So it is very similar to the coplanarity concept what you did earlier, finding two plane equations if the lines are given in unsymmetric form. Did you get that? Have you seen the notes now? All right, I will go with the procedure. So for the first line, I will apply pi 1 plus lambda pi 2 equal to 0. So I am calculating the plane passing through L1. So if you apply that, can I write the coefficients values straight away? Is it convenient for you to understand? Okay. So taking x coefficient, so 3 plus lambda into x plus minus 9 plus lambda into y plus 5 minus lambda into z equal to 0. So this is the plane equation passing through L1. So for L2, I will take that pi 3 plus mu pi 4 equal to 0, taking the respective values. 6 plus mu into x, 8 plus 2 mu into y, 3 plus mu into z, minus 10 minus 3 mu equal to 0. So we are choosing the planes passing through L1 and L2 in such a way that they are parallel. So if they are parallel, the coefficients are proportional, so that you have 3 plus lambda by 6 plus mu equals to minus 9 plus lambda by 8 plus 2 mu equals to 5 minus lambda by 3 plus mu. That equals to the proportionality constant k. So that if you equate each thing with k, you will get three equations in lambda, mu and k. So first we solve the product variable mu k, then you can determine lambda, mu and k as well as. So is it required for you to write the equations and solve them, or you know the procedure already? Right. Then straight away I will mention the values. So for this problem, I will say you will get that lambda is equal to 53 by 5, k is equal to 32 by 5 and mu is equal to minus 31 by 8. So please understand that for this problem, the values appeared are somewhat little difficult. That means there are some good numbers. Seems to be very difficult. But actually for the other problems, you cannot get such type of big fractions for the simplification part. So this problem, the values have happened to be like that. So if you substitute the respective values, lambda and mu, the parallel plane equations, what you are getting is 17x plus 2y minus 7z equal to 0. That is the first plane. Second one, 17x plus 2y minus 7z minus 13 equal to 0. So the checking condition here is, after finding the plane equations, the coefficients must be equal, because you are finding the parallel planes. So if they didn't come like that, it means that you did a mistake in evaluating the values of lambda, k and mu. That's it. That is a checking thing. The planes what we have arrived are right or wrong. So since the planes are parallel, the distance between them is nothing but the shortest distance. So the formula is, I think you have known that formula, modulus of d1 minus d2 by square root of a square plus b square plus c square. So d1 minus dt is nothing but 13 by square root of 284 plus 4 plus 49. So simplifying that, you will get the result as so that is the SD. So here I have avoided writing the simplification part of equations, because you did the same thing under coplanarity of lines when two lines are given in unsymmetric form. So I have skipped that. Is it necessary for anybody? If not, I will write. So please take a note of this. So compared to the other models, calculating SD and line of SD when two lines are given in unsymmetric form is a little bit lengthy. Obviously, if such type of question examination point of view, the weightage should be at least 18 marks. So as per the new approach of UPSC, you can expect the question weightage would be around 15 marks. But it takes a time, at least it will take 15 minutes to do the whole problem. But it is the easy thing. The approach is easy once you understand the logic. So if you are clear with calculating SD, then I move with calculating line of SD. Right. Now, calculating line of SD is very simple. You have done a previous problem, right? You have represented line of SD in unsymmetric form. I have shown a small visualization that you fix one plane, you find one plane on the top, one plane on the bottom, so that intersection of these two is nothing but line of SD. Did you get it? So we do the same approach here. So among the two planes which already found by us, I fix one plane. Let me say I am fixing the first plane. So I am finding two planes. I will draw the picture, then it will be very comfortable for you to get an idea. So this is line 1, this is line 2. So I fix the first plane which is already there. Now this is the line of SD. So I calculate a plane which is passing through L1 and perpendicular to this one, the plane which is already there. Again, I am calculating a plane passing through L2 and perpendicular to the previous one. So intersection of these two is nothing but the line of SD. Fine. Is the visible thing comfortable to understand? So among the two planes, what I did, I am considering this plane. Again, these steps are common. Pi 1 plus lambda pi t equal to 0, taking the values common. So this plane and this plane both are perpendicular. What it is? It is passing through L1 and perpendicular to this. So same equation, same substitution, same values will come here. So applying perpendicularity condition, 17 into 3 plus lambda plus 2 into minus 9 plus lambda plus 5 minus lambda into minus 7 equal to 0. So if you simplify that, you will get lambda is equal to 1 by 3. And obviously, the equation of that plane is nothing but 10x minus 29y plus 16z equal to 0. This is the plane. Again, these steps are common again. We write pi 3 plus mu pi 4 equal to 0. Again we consider, we take the values as common and these two are perpendicular. So we apply perpendicularity condition. So 17 into 6 plus mu plus 2 into 8 plus 2 mu minus 7 into 3 plus mu equal to 0. So if you simplify that, here the value of mu will come somewhat different. It will come as mu is equal to minus 97 by 14. So if you substitute the values, you are going to get it as 13x plus 82y plus 55z minus 151 equal to 0. So the line of SD is nothing but we write these two planes together with a common 0 indication. So it is nothing but the line of SD. The overall thing is simply applying the technique pi 1 plus lambda pi t equal to 0, pi 3 plus mu pi 4 equal to 0. It takes the only computation process, except that no separate logic is there in the evaluation. Okay. So please take a note of the problem, then I discuss with others. Other problems I want to discuss. So that's minus 26. Okay. For this one you are saying, right? 26y and 14z, right? Yeah, I will change that. Thank you. So this is the problem. So please take a note of it. After noting the problem, please tell. So here, if you observe that planes through OX and OY include an angle alpha, it is nothing but OX is x-axis, OY is y-axis. So here you are considering a plane passing through x-axis, a plane passing through y-axis. And it is mentioned that if you consider those planes, they contain an angle between them. The angle is alpha. So as we know, if the both planes intersect, then only we have the angle alpha. So intersection of planes is nothing but a line. So that line satisfies this equation. That was the objective of the question. Fine. Can you visualize that? So what is the equation of OX, x-axis? It is nothing but y is equal to 0, z is equal to 0. The equation of x-axis. So if you consider a plane passing through x-axis, it is nothing but the formula pi 1 plus lambda pi 2 equal to 0, nothing but y plus lambda 1 z is equal to 0. That was the thing. Similarly, y-axis, the equation is nothing but x equal to 0, z is equal to 0. If you consider the plane, it is nothing but x plus lambda to z equal to 0. So these are the planes passing through x-axis as well as y-axis respectively. So if you consider that the angle is alpha between 1 and 2, let us apply cos alpha formula. So cos alpha, if you apply that, 0 plus lambda 1 into lambda 2 by square root of 1 plus lambda 1 square into square root of 1 plus lambda 2 square. So I have applied the cos theta formula. Any queries to anyone up to this step? Now let us take the reciprocal on both sides. Let us square on both sides, so that secant square alpha equals to 1 plus lambda 1 square into 1 plus lambda 2 square whole by lambda 1 square into lambda 2 square. So take this value to this portion, you can multiply the numerator values. Simplification is very easy. So as you know that secant square alpha minus 1 is equal to tan square alpha. Substituting that, you will get 1 plus lambda 1 square plus lambda 2 square is equal to lambda 1 square into lambda 2 square into tan square alpha. That thing you will get. Could you do the simplification on your own? And can you give the confirmation you are going to get the same equation like this? Check on that. Do on your own and give the confirmation. Anybody is getting any difficulty in this problem to have the idea? All right. Now, if you eliminate or if you remove the values of lambda 1 and lambda 2 by suitable substitution, which is the required locus or required condition. So, if you observe the plane equations what you considered earlier, lambda 1 is nothing but minus y by z and lambda 2 is nothing but minus x by z. So if you substitute these values in this expression, it is nothing but our required locus. You can check that on your own. It's very easy. That's all. So this is the solution of the problem. Fine. Now I am going to take the other models. Can I proceed? Yeah. Just give me a moment. I think these questions are given earlier in the previous year problems. I hope so. However, let us discuss that. Show that so these two lines are given in symmetric form. The question tag of the problem is we have to show that they are coplanar and we have to find the plane containing them. Two things we have to do here. This type of problem we already did while discussing with the coplanar concept. The thing is, there you have simply numbers. Here you have the things alpha, beta, gamma, the variables are involved, the constants are involved. So let us discuss the case. So finding the plane containing them is very easy. I have given the determinant formula. Right? So can you imagine the determinant formula what I said? Determinant of x minus x1, y minus y1, z minus z1, L1, M1, N1, L2, M2, N2 equal to 0. So can you recall this formula? Right? So it is justly substituting the values there, nothing but so if you do the straight away the determinant expansion, it is okay. Otherwise, if you know the properties of the determinants, then by applying them, you can easily find the equation of the plane. So I will say that you can do the part that C1 tends to C1 plus C3. I am using the properties of determinants. There is no restriction that you should do in the same manner. You can do your own properties. Then it is going to happen as x plus z minus 2a, y minus a, z minus a plus d, 2 alpha, alpha, alpha plus delta, 2 beta, beta, beta plus gamma. So again, you can do that. C1 tends to C1 minus 2C2. So that these two parts will become 0. Hence, you have the determinant x plus z minus 2y, y minus a, z minus a minus d. To be a plus d, right? Yeah. So you can expand determinant based on any one column. So in the problem, you just need to do a small modification that here it should be a minus d. Then only it will become minus 2a here. Do you agree? Accept it all? Right. So please take a note of that. So that if you simplify the determinant by expanding over the first column, I will say you are going to get the equation as x plus z minus 2y is equal to 0. I hope that this is the equation. So in this way, we will calculate the plane containing them. And how to check the coplanarity? It is also based on determinant formula. Whenever two lines are given in unsymmetric form, we simply do the substitution of drs in the determinant and we will check whether it is 0 or not. So it is just like the formula x2 minus x1, y2 minus y1, z2 minus z1, L1, M1, N1, L2, M2, N2 equal to 0. So if you observe that here, the point is A minus D, here the point is A, here the point is A plus D. So here the point is B minus C. Here the point is B, here the point is B plus C. So if you substitute the values in the determinant, it is doing determinant of B minus C minus of A minus B, B minus A, B plus C minus of A plus D. Denominator values are same. alpha minus delta, alpha, alpha plus delta, beta minus gamma, beta, beta plus gamma. So these are denotes: x2 minus x1, y2 minus y1, z2 minus z1, L1, M1, N1, L2, M2, N2. So simply you can expand the det, the result will be 0. That's it. So the difference between the regular problems and this problem is, it involves the determinant properties if you know, otherwise straight away you can expand the det. Nothing wrong at all. It takes the only computation time. So if you have noted this, can I take the other one? So here, by doing determinant properties, two rows will be equal, so that the determinant will be 0. Probably you can do the operation as, you can do that C1 tends to C1 plus C3. That operation you can do. Then the first two columns will become identical, hence the determinant will be 0. Not one column, I can say, yes, one column completely 0, that is 0, or two columns are same, so that is 0. That we do actually. That's it. Fine. If two columns are equal, then the det is 0, because while subtracting, one column will become 0 completely. Yeah. Applying the same operation, C1 tends to C1 plus C3. If you take two common in the first column and second column will be identical, so that will be 0. There is no need to evaluate the det. That's it. So let us take the other one then. So here the problem is, please take a note of this. Right. Now here in the problem we got three lines. All the three lines are given in symmetric form. X by alpha is equal to y by beta is equal to z by gamma, one line. Similarly, the other two lines are given. Now the question tag is, if you assume that all the three lines are on one plane, in other words, they are coplanar, then the condition will be L by alpha into B minus C plus M by beta into C minus A plus n by gamma into a minus b is equal to 0. In other words, by assuming that the three lines are coplanar, you have to show that the condition will be satisfied. Clear? Now, if you roughly observe that all the three lines having no point in the numerator, it is nothing but all the three lines are passing through the origin. Agree? So, if you imagine that this is the plane which is containing the three lines. So, what happens, since all the three lines are passing through origin, if you draw a perpendicular from origin to this plane, it will be perpendicular to the three lines. Accepted? So, I am considering a line which is passing through origin and perpendicular to the above three lines. In other words, the line acts as a normal to the plane, where the plane contains all the given three lines. So, if you write the line equation, numerator values are 0, 0, 0, the point is 0, and let us assume that the DCs of that line will be, for our convenience, Z, eta and delta. Let us take like that. Or you can take the other symbol, say this symbol we can also use. Delta will be convenient for understand, because delta is not at all used. So applying perpendicularity condition, so these are nothing but DCs of line through O and perpendicular to above three lines. So you are saying it is PQR for our convenience. So symbols difficult will not be there. Yeah, let us write like that. That's fine. So if you apply perpendicularity condition there, it is simply alpha p plus beta q plus gamma r equal to 0. There, a alpha p plus b beta q plus c gamma r equal to 0, and here lp plus mq plus nr equal to 0. Now, the technique here in getting the required result is very simple. So I will solve the first two equations so that I will get the values of PQR. Right? I have given the cross multiplication method like earlier, A, B, C, A, B. By substituting, doing the cross multiplication. Can you visualize that method while calculating the DRs? So here also I am doing the same thing. So if you do like that, the values happen to be Again, if you common the values, it will be so it is nothing but you have taken the proportional values of P, Q are here. So P is nothing but C minus B into beta gamma, QV is nothing but A minus C into alpha gamma, and R is nothing but B minus A into alpha beta. Okay. Now, in the third equation, in place of P, Q, R, I am substituting these values. And I divide with alpha, beta, gamma, then I get the required equation of the locus. So I will substitute PQR values in the third equation. I divide the total equation with alpha, beta, gamma, then I will get that L by alpha into something, M by beta into something, plus N by gamma into something is equal to 0, the required answer. That was the idea here. Clear for everyone? Please take a note of it. Then I discuss one more problem. There we can conclude. I think these three questions are given earlier in the previous year papers of solid geometry. I hope so. So this is the problem. Show that the lines x by alpha is equal to y by b beta is equal to z by c gamma, x by alpha by a equal to y by beta by b is equal to z by gamma by c, and x by alpha is equal to y by beta is equal to z by gamma. All the three lines are coplanar if either a is equal to b or b is equal to c or c is equal to a. That's it. So the problem is also very similar. Just like the previous thing, what we did, if you observe that for all the three lines, they pass through the origin because the numerator is 0, 0, 0, the point. Did you get that? Right. And as usual, let us take a line whose DCs are LMN. So if you observe that the three lines are coplanar, all the three lines belong to this. So if you are calculating a line starting from 0, 0, 0 to perpendicular to this plane, it acts as a normal to the plane. Hence, if you consider that LMN are nothing but DCs of this line, so we apply perpendicularity condition for them. So if you apply the perpendicularity condition, it will be A alpha L plus B beta M plus C gamma N equal to 0. Therefore, the second one, alpha by A into L plus beta by B into M plus gamma by C into N is equal to 0. And you have alpha L plus beta M plus gamma N is equal to 0. So, if you solve the three equations, then you will get the required condition that either A is equal to B or B is equal to C or C is equal to A. In other words, if you calculate the determinant for the coefficients, you will get the required condition. Now, how we are evaluating? So if you observe the three equations, that in each equation this term is common. Alpha L, beta M, gamma N. In each term or in each equation, these three terms are common. So if you treat them as the variables, if the three lines are coplanar, the determinant of the coefficients must be equal to 0. So it is nothing but A, B, C, 1 by A, 1 by B, 1 by C, and 1, 1, 1 equal to 0. So determinant can be expanded by using any row or any column. So if you expand the determinant, you are going to get it as B minus A into C minus A into C minus B is equal to 0. It is a simple determinant. There is no need to apply any properties of determinant, etc. Now the thing is, if you want to say that the product is 0, one of the values must be equal to 0. So you should have, if you take that B minus A is 0, you should say that A is equal to B. If you consider this term, A is equal to C. If you consider this term, B is equal to C. Hence you have arrived with the conclusion. That was the solution of this problem. So compared to the previous one, it is very easy. Fine. But the logic is very same and similar. So here I want to conclude our discussion on the concept of right lines. So from the next class onwards, we will discuss about the spheres topic. Right? So that's all for today.